Hello, are we live? I think we're live. Hello and welcome to the fourth installment of the ExamRiz GCSE Maths live sessions. I'm going to be going through a few different topics today, starting off with some graph transformations. I hope you all had a wonderful Christmas and New Year, um, and are ready to start back at school now. I think everyone's back at school. Now, some people went back quite early, some people went back quite late. But I bet it's hit you like a ton of bricks, right? Taking a nice Christmas holiday, you get back to school, it's a bit of a shock to the system. So I am here to try and help guide you through that, at least a little bit, with a few topics that are the more advanced topics in the GCSE syllabus. Don't know if some of you have mock exams coming up soon. Um, but uh, but either way, I'm sure you've all got the exams coming at the end of the year, and those 4 and a bit months will fade away very, very quickly. So let's get started with one of my favorite topics. This is graph transformations. It's one of my favorite topics. Why? I don't know why, to be honest. I just like it. It's one of those things that looks really, really horrible, but actually it's quite simple when you boil it down. If you understand the few basic rules, then you can just apply them every single time and it will always work. And I like stuff that can be distilled into something quite simple like that. So, many of you may have seen stuff like this before. So we got a curve there. We told the maximum point is 1, 4. And the question says the coordinates of the maximum point of this curve are 1, 4. Write down the coordinates of the turning point of the curve with equation, and then we have 4 different equations here. Before we get into the individual questions, what I want to do is explain the rules that come with this. So graph transformations, basically there's 4 types of transformations. There's X transformations, Y transformations, shifts, and stretches. X transformations only affect the X coordinates, which are on the horizontal axes. So side to side, stretched wider, or squished narrower. Those are what X transformations do. Y transformations do the exact same thing, but up and down. So they shift the graph up or down, or stretch it, make it taller, or squish it, make it shorter. Those are the only things that can really happen, except for later on where we'll get to a bit of reflection, but don't worry about that right now. The way to identify them, now this is the key to the whole thing. If the change that happens, and when I say the change, the original curve has equation y equals f of x, that is just always, pretty much always going to be the original curve. Then you notice in these questions, the change, this one says f of x plus 3 minus f of x minus 3. So the change in all of these is the plus 3, the negative, the minus 3, and the other negative. Those are the changes that I'm talking about, how it differs from f of x. When we look at those changes, there's 2 questions we've got to ask ourselves. First of all, is the change inside the brackets or outside the brackets? If it's inside the brackets, it's directly affecting the x. So that's going to be the case with this one. This 3 is inside the bracket, therefore directly affecting the x. Therefore, it's going to be an x transformation. The one down here, this minus 3, that change, the negative 3, is outside the brackets. It is not directly affecting the x, so it's going to be a y transformation, therefore only affecting the y coordinates. The idea here is that x transformations only affect the x and y transformations only affect the y. So let's actually get to this first question. Y equals f of x plus 3. We've already identified it's an x transformation. Plus 3, quite simply, whatever the change is, that is what happens to the coordinates. Unfortunately, there's one more trick we've got up our sleeve here, or rather they have up their sleeve, and that is that x transformations do the opposite of what you expect. So those are the things we need to remember. Identify if it's an x transformation or a y transformation by whether it's inside the brackets or outside the brackets. Remember that x transformations do the opposite of what you expect. And then ultimately, whatever the change is what happens. So because the change here is a plus 3, we will expect to add 3 to all of the x coordinates. But remember, x transformations do the opposite of what you expect. So we actually minus 3 from all the x coordinates. The implication of that is that this graph would shift 3 to the left. And this coordinate up here would become -2, 4. That is the answer to that first question. So the coordinates at the turning point would be -2, 4. And you'll notice the y coordinate stays exactly the same because x transformations don't affect y coordinates. Let's try the next one. So I'll erase what we've got up here, but I will keep the answer to that first question. Next up, actually, we're going to skip B. We're going to come back to it. We're going to skip it for now. I'm going to jump straight to C. This one actually should be a bit easier. The change is on the outside, so it's a y transformation. So it only affects the y coordinates. In fact, it only affects the y coordinates. We're so confident about that. We can write the answer of our x coordinate straight away. We could just write 1 because this transformation is not going to affect the x coordinates, so we just keep the 1 as a 1. Then what is the transformation? It's a -3, which means we're going to subtract 3 from the y coordinate, which creates 1, 1. The implication on the graph is that the whole thing would shift down by 3. So it would end up being something like that. But all we need to care about is that maximum point and what happens to that coordinate. All right, let's go back to part B. The change is on the outside, meaning it only affects the y coordinates. So I think we can put our x coordinate just as 1 still. It ain't going to change. The transformation here is that f of x has been multiplied by -1. So we are going to multiply the y coordinates by -1 as well. So we are literally doing whatever the change is, that is what we're doing. So this is going to become -4. I'll repeat that again. F of x, the original equation, up here, in this question, sorry, not that one, in this one, has been multiplied by -1. We've identified it's a y transformation, so the y coordinates are going to be times by -1. That is how we do it. And then D, I wonder if you can figure this one out yourself. Have a look at it. The change is on the inside, x transformation. So we can straight away just write our y coordinate. I think that's a good tactic in situations like this. Write your y coordinate down. What is happening to the x? It has been multiplied by -1. Now here comes a little trick. X transformations do the opposite of what we expect, right? That's what we said. This x has been times by -1. So times in by -1. What's the opposite of multiplying by -1? Now I know what a lot of you are thinking. Multiply by +1. No, that is the mistake that everybody makes. The opposite of multiplying by -1 is dividing by -1. The implications in this case is it has the same outcome. Multiplying something by -1 and dividing by -1, the outcome is the same. So we are going to multiply or divide our x coordinate by -1, which would create -1. So that may seem like a lot at this point, but that's only because it's the first question. We've got a few more examples we're going to go through, and hopefully as we go through, as we repeat, repetition is the key to maths. As we repeat, it should become a lot simpler. So let's go to our next question here. I'll go over those rules again. We need to remember how to identify if it's an x or a y transformation. If it's the change is inside the bracket, it's an x. If the change is outside the bracket, it's a y transformation. Whatever the change is what happens to those coordinates, except x transformations will do the opposite of what you expect. So let's see this one. Part A, the change is inside the bracket, so it's an x transformation. It is a +2, but we're going to do the opposite of what we expect because it's an x transformation. So we're going to -2 from only the x coordinates. So that's going to create 0, -3. Part B, it's a y transformation because the change is on the outside. So we are going to only be affecting the y coordinates, and it's being multiplied by -1 or being made negative. So the signs of all of the y coordinates are going to change. So x stays the same because it's a y transformation, and this becomes a +3. Next up, we got a y transformation It's clear as day, right? If the change is outside the brackets, it's a y transformation because it's not directly affecting the x. So we're only going to touch the y coordinates, and we're going to plus 2, meaning quite literally the whole graph will shift up 2, because this is the y direction after all, up and down. Shifting up 2, meaning this coordinate is going to go up 2 to become 2 minus 1. And finally on this question, remember these negatives essentially result in reflections, flipping, but we'll get to that when we actually have to draw them. X transformation, so the y coordinate will remain as -3, and the x coordinate gets multiplied by -1, so it becomes -2. Okay, I think these basics are pretty good now. If you and just once again, if you guys have any questions, or you're not understanding something, just leave a comment, let us know, and I will do my best to go over it or find another way of explaining it. That's the whole point of these interactive sessions. Otherwise we could just upload a TikTok video. So make the most of it. Right, we've got another one here. I'm going to give you guys a minute, not a minute, a few seconds. Have a look through it. See if you can think of the answer yourself. Then when I write down the answer, you can give yourself a little pat on the back if you got it right. Give yourself a little slap on the face if you got it wrong. Have a think, have a think. What have we learned so far? That's correct. It's an X transformation. I can read your thoughts. I know you're saying X transformation. I'm very, very happy about that. Does the opposite of what we expect. Very good. So what's going to happen? The X coordinate is going to be added 3. So that creates 1, 1. I like it. Well done. What about this next one? X transformation. Yep. X coordinate gets multiplied by -1. The Y coordinate stays exactly the same. Now hold the phone. What have we got with part C here? There are 2 transformations happening. This is the first time I've come across anything like this. I know it's scary. I know it's daunting. But if we take it step by step, I promise you it's going to be fine. The good thing about X transformations and Y transformations is that they do not affect each other. As we discussed, an X transformation does not affect Y coordinates and a Y transformation does not affect X coordinates. Right now we have a Y coordinate, the bit's on the outside, and we've got an X coordinate, the bit's on the inside. Doesn't matter which order we do them because they do not affect each other. So let's deal with this one on the inside first because I think it looks a bit nicer. That's the X transformation. It says +2, so we are going to -2 from all of the X coordinates. So that means it's going to be -4. But let's not write the Y coordinate yet, because remember, that's still got its own transformation. So it's a negative, meaning it has been times by -1. So the Y coordinate is going to get times by -1. And it is a 1, so times by -1 is just -1. Now that we've survived our first 2 transformation question, I'm sure you'll be able to do the second 2 transformation question. Y equals f of -x, take away 1. Once again, we've got an X transformation and a Y transformation, so it does not matter the order in which we do them. But I'd like to think because we're confident in this now, let's try the X one first. So a -x means the X coordinate is going to be made negative, or if it's already negative, made positive. So that's going to be a 2. And then we're going to subtract 1 from all of the Y coordinates, meaning that will be 0. And that is it. So now we're going to do some drawing. I do enjoy drawing graphs. It brings out my artistic side. Makes a bit of a change from writing out equations and all of that shit. Getting to draw something nice, making it look good. Unfortunately, I'm terrible at drawing, so it won't look good. But I'll do my best. The graph of y equals f of x is shown on both grids below. So this is just the standard graph they're giving us, y equals f of x, the original one. On the grid above, sketch the graph of y equals -fx. So my advice here, as we've been doing in the previous questions, is we had a coordinate that we transformed. You can do the same here. If you want to pick 1 or 2 or maybe 3 points on this curve, transform them individually, then that might be a really good way of sketching this curve. So let's have a look at the transformation. It is a y transformation, as we can see, because the change is on the outside. It's a negative, meaning all the y coordinates are going to be multiplied by -1. So if we take this coordinate up here, that's 0, 5, the y coordinate being 5. So when you times that by -1, it becomes 0, -5. So that gets reflected down here. This coordinate here is 2, 5. With the transformation, that's become 2, -5 down here. What about this one? That coordinate is 1, 0 times the y coordinate by -1. That becomes, well, remains 1, 0. So that stays there. So we're going to end up with a nice curve that looks, hey, look at that. That is pretty good. I'm pretty proud of myself with that drawing. I've got to be honest with you. And if anybody wants to tell me well done on that drawing, I really appreciate it. My confidence in drawing is very low. So I'd really appreciate any positive reinforcement of that drawing. And if you've done a drawing yourself that's like that, congratulations to you as well. I'm asking for positive reinforcement. I'm giving it as well. Let's try the next one. On the grid above, sketch the graph of y equals f of x plus 2. Now, we should know, clear as day, what type of transformation this is going to be. It's inside the brackets, so it's an x transformation. It says a plus 2, meaning we're going to do the opposite because it's an x transformation. So we are going to -2 from all x coordinates. That means this one, 1, 2, goes here. This one, 1, 2, goes here. And this one, 1, 2, goes here. The graph is going to look like that. I did that bit of a sharp point in the bottom. I'm not too happy about that drawing, but it will be okay. I'll give myself the benefit of that with that one. Got a nice comment here from Song Kim. Well done. Face blue smiling. Face blue. I assume that that's the text for an emoji of a blue smiling face. Thank you very much. I really, really appreciate that. One trick that they're trying to trip you up with on this question is each square counts for a half. So to move one square, to move one sort of number on the graph, you need to go 2 squares. So don't fall for that. What they want you to do, and I'll do it in a blue pen right now, what they want you to do is move 2 to the side and end up looking like this. Because you've counted 2 squares, but ultimately you've only moved one number across on the graph. So always keep an eye open for those tricks. Whenever it's a graph, always look at the scale of the graph. They may be trying to catch you out. You don't fall for it, all right? We don't fall for it. That's not the game we play. Next. Right, they're asking us to sketch y equals f of -x. X transformation. All x coordinates are going to be multiplied by -1. So this, we have an x coordinate of +1. That's going to become -1. This x coordinate of 0, that stays as 0. So it stays right there. And this coordinate of 2 will become -2, all the way over here. That's going to be a nice curve like that. Interestingly, that curve ends up being exactly the same as the one above, where it shifted 2 to the left, or it reflects, just goes to show there's multiple ways of getting the transformation over there. But yeah, just an interesting thing to note. And I think this is the last one on this. No, it ain't. Oh my gosh, we got so many. We don't need to do all of these. But I think drawing them is a really important skill to have. With this one, y transformation, -2. We can be very literal with these equations. If it's a y transformation, it says -2, we quite literally move it down 2. So that can be quite simple, just like that. I think we probably can skip a couple of these. I think they're basically all going to be the same. And same with that one. Actually, no, let's round this one off. This would be a nice one to do. To finish off our topic on graph transformations. So, on the grid above, sketch the graph of y equals f of x minus 1. X transformation, opposite of what you expect. It says -1, so we are going to +1. And remember the scale on here. So if this is going across by 1, it's going to go there. This point is going to go here. And this point is going to go there. And it's a real nice curve like that. Horrendous at the end. Oh my gosh. And I'm just making it worse. I know I am. Oh no, I'm making it better now. That's a skill I've learned when it comes to drawing just in general. If you just go over the line multiple times, then your eye kind of tricks you into believing it's one solid, nice line. Kind of. Part B, the graph of y equals f of x. Now, this is where they're trying to trick you. Part A was about drawing this transformation. Part B is nothing to do with that transformation. Graph of f of x has turning point at minus 1, 2. Yeah, that's here. Right down the corner is the turning point of this new transformation. So quite a few people, well, some people may fall for the trick and say, well, we've just transformed it. It's going to be this turning point here. I'm not sure if you could see where that, but that turning point there. They want you, that's where they're trying to trick you. You have to spot that this equation is different from this one. So we need to do a brand new transformation. So let's go ahead and do that. So two transformations happening here, 1x, 1y, so they do not affect each other. So we can do them one after the other. The negative x, so this original curve is going to be multiplied by minus 1. All the x coordinates be multiplied by minus 1. So this one is going to go over here. This positive one is going to go to negative 1. And this negative 3 is going to go to positive 3, making it look like that. And then we need to add 2. So I'm going to do this in a different color now. Then the y transformation is plus 2, shifting up 2 to get us to here, here, and here. This is why it's really important to take a pencil into your exam, because this looks messy as shit, right? But if you got a pencil, you got rubber, you can rub that shit out, make it look nice and neat. So yeah, always take a pencil and a rubber as well as a pen, and a ruler as well, and calculator, and obviously everything else. So that's graph transformations. I hope that makes sense. There weren't any multiplication ones in there. And I'm wondering, I'm going to write my own multiplication one, because in case that shit comes up, I do not want you guys to be deficient in that area of knowledge. So the same rules apply though. So it's going to be pretty straightforward. Let's say, get rid of that question there, and it will be more like y equals 2. No, not 2 f of x. F of 2x. Let's do that. F 2x. So we have an x transformation here. The change is an x transformation because it's inside the bracket. The x is being multiplied by 2. So we do the opposite of that. We divide by 2. So every x coordinate is going to get divided by 2. So this x coordinate, that was a 2. That's going to go to here. This is a 1. It's going to go to a half. And the 0 stays at 0. So what we find is that it really squishes it. Something that should expand by scale factor of 2 actually halves in size and gets a lot smaller. So that's how we deal with those type of transformations. Let me try one with the y-axis now, and you'll be able to see that. Let's say, actually, yeah, no, that's fine. That's fine. Let's do the one I decided against earlier. 2f of x. Y transformation, because because the change is happening on the outside. All the y coordinates get multiplied by 2, meaning that, well, it's going to be pretty difficult to see on this one, but the 0 stays at 0. Then this 5 is going to go up to 10 somewhere up here, as is that one. And it's going to end up looking something like that, just really stretched along the y-axis. Okay, we'll move on. But maybe if we have some time at the end, we'll come back to this, because I think it's always nice at the end of a session to do a little bit of a recap. So we will have that as an aim later on. Okay, next up we're going to move on to, well, what is a jam-packed topic of quadratic simultaneous equations. Now, I'm sure many of you have come across these before and have looked at it and thought, I have no idea what is going on. Now, these questions are usually 4 or 5 marks. This one is 5 marks, it says at the bottom there. And the reason why it's so many marks is because there's so many stages to go through. The downside of that is there's so much knowledge you need to have to be able to do the whole thing. But the positive side of it is that even if you know a couple of things, you can get a couple of marks. This is an example of one of those questions that almost certainly is going to come up at the end of the paper. Majority of people aren't going to know how to do it. And I've said this about particular topics before. If there's particular topics that some people do not know how to do, and you can get 1 or 2 marks on them over the course of all your exams on those type of questions, if you can pick up 1 or 2 marks, that's going to actually make a huge chunk of difference. So these questions, don't just discount them and say, I don't know how to do it. Let's at least try and get the first few marks. But our aim today with quadratic simultaneous equations is I am going to hopefully teach you how to do from beginning all the way through to the end. But we are possibly going to take some detours and focus on some other topics within this that you need to be able to nail to be able to do it. So regular quadratic equations are often when we make either the x value or the y value the same, so we can eliminate them, either add the 2 lines together or subtract them to eliminate the x's or the y's. That's not going to be the case with this one. The reason why we know that is because this top line have got squareds in them and the bottom line do not. That means we cannot subtract these from each other. Instead, we're going to use substitution. So the aim here is to make x or y, either x or y, the subject of one of them, and substitute it into the other one. So they've been quite nice here in that the second equation they've given us, x equals y minus 5, x is already the subject. So what that is saying is that x is y minus 5. That's what an equals means, basically. Equals is just the notation for the word is. X is y minus 5, which also means that this x up here is y minus 5. And that's how we do substitution. So we're going to rewrite this top line, but instead of the x, we're going to put y minus 5 because x is y minus 5. So y minus 5 squared instead of the x squared plus y squared equals 13. Now, hopefully you've understood exactly what we've done so far. All we've done is replace the x on the top line by what we're told x is equal to. Now, the next step, when you have a bracket squared, a bracket with a sum in it that's squared, what I want you to do is write that bracket out next to itself. Because that's what squared means. It means multiplied by itself. So y minus 5 squared means y minus 5 times y minus 5. Then plus y squared equals 13. So we're just writing out that bracket squared into 2 brackets next to each other. The reason why I want you to do that is because when you see these brackets, then that reminds us that we do the full expansion. A lot of people make the mistake of just doing y squared take away 25 squared. But that's not right. You need to write out, so you do a full expansion, and you get y squared minus 5y minus another 5y plus 25. And then we'll just combine these in this next step. Y squared minus 10y plus 25 plus the other y squared equals 13. So we've fully expanded the brackets. Remember, in algebra, there are 2 things we don't like: fractions and brackets. When I say we don't like them, I just mean whenever we have them, it should be our instinct to multiply them out. And that's something really, really important when it comes to algebra. Fractions and brackets. It is our instinct to get rid of them. So we've done that, which means we've got everything in one nice line here. And I'd like to think you can spot at this stage that it's going to be a quadratic. When I say a quadratic, I mean something that has the structure x squared x number. Here we've got a y squared, we've got a couple of y squareds, we've got a y, and we've got some numbers. Because we have all those things, we should notice it's going to be a quadratic. Now, when something's going to be a quadratic, we need to treat it like one. So the aim here is to move everything on the same side and make it equal to 0. So these are instincts, I suppose we could call them, but it's something we need to learn to get that instinct. We need to do enough quadratic questions, enough algebraic questions to start spotting when a quadratic occurs so we know how to deal with it. Collect like terms, move everything onto the same side. So we got y squared, we've got another positive y squared, so that's going to create 2y squared. The 10y comes after. And we're going to minus the 13 onto the left-hand side, minus it to the 25, because we're collecting like terms. Squareds go with squareds, the y's go with y's, and the numbers go with numbers. So 25 take away 13 is going to leave us with positive 12. And now that's going to equal 0. So we're in a position where we can start to solve this quadratic now. But we can help ourselves out a little bit. This is another little trick or tactic that we have. All of these terms are divisible by 2. Because it's currently equaling 0, we can sort of do a balanced equation. Whatever we do to one side, we can do the same thing to the other side. So we can divide everything by 2. It's not a necessary thing to do, but it's super helpful. And it means the quadratic equation that we're about to do becomes a lot easier. Y squared minus 5y plus 6 equals 0. Now, once again, our instincts should tell us factorize here. Factorizing is the aim. Y. Remember, we're looking for two numbers that times together to make 6 and add or subtract to make minus 5. So I'm thinking 2 and 3, but negative 2 and negative 3, because negative 2 take away 3 equals negative 5. That equals 0, and we should know at this stage that means y equals 2, y equals 3. If you're not exactly sure how I got that, or any stage in this, please let me know. We're going to be doing a couple more questions like this, so I'll perhaps slow it down at whatever particular stage you may need, and I'll be able to go through it again and maybe explain it in a different way. But let me know if there is anything you need. Unfortunately, we're only halfway to the answer. We've got the y equals 2 and y equals 3, but we haven't found what x is. Thankfully, we've got our original equations all the way up at the top here. And we're told, create a bit of a separation here, and we're told that x equals y minus 5. So we have two y answers. Let's use each of those to get an equivalent x value. So x equals, remember one of our y values was 2. So let's say 2 minus 5, which is minus 3. And the other option is x equals 3 minus 5, which is going to be minus 2. So our x values are minus 3 and minus 2, and our y values are 2 and 3, which I wrote at the bottom there. It's a lot of work, but it's worth a lot of marks. So it's definitely worth it. Let's try another one. But before we do, I'm just going to state the steps that are involved. So we're going to substitute one equation into the other to eliminate either the x or the y's. In regular simultaneous equations, we do subtraction to eliminate them. But here we're going to do substitution to eliminate them. Then it's just algebra from this point onwards. Expanding brackets, collecting like terms to create a quadratic. Then we're solving the quadratic, getting our value for either x or y. And at the very end, the last thing we do is plug it into one of the original equations to find the other value, to find the other answers. So let's put that to the test now. Solve the simultaneous equations. X squared plus y squared equals 17. Y equals x minus 3. So I'll zoom in a little bit so we can see it a bit bigger. Okay. So once again, they've been very kind and made y the subject. So we're going to plug that value of y into the one above. So instead of this y here, we're going to put x minus 3. So let's write that out. X squared plus brackets x minus 3 squared equals 17. So at this stage, all I've done is substitute the x minus 3, which is equal to y, into the y. Now, classic algebra. Expand the brackets, collect like terms. The original x squared stays as it is. We write out these brackets next to each other. X minus 3 equals 17. X squared plus x squared minus, and I'll group these together just to save us a bit of time and space, minus 6x plus 9 equals 17. So that minus 6x comes from the minus 3x minus 3x. Just combine it in one step. Collecting like terms creates the 2x squared. I'll tell you a mistake that really gets on my nerves. It happens all the time. X squared plus x squared. It's not x to the power of 4. It's 2x squared. Just try and remember that. When you're adding algebraic functions, the powers don't change. You're just literally counting how many you have. It's when you multiply them together, that's when the powers change. So really try and remember that, because it's a mistake that a lot of people make. And it's very, very easy to avoid. Minus 6x, and then we're going to minus the 17 over to this side, which will, of course, create minus 8 equals 0. When we have a quadratic that's equaling 0, that's when we're happy, because that's when we can factorize. But we always check, can we divide by anything at this stage? The answer is yes, everything is divisible by 2. So let's divide it all by 2. X squared minus 3x minus 4 equals 0. And let's factorize. So we're looking for two numbers that times together to make minus 4 and add or subtract to make minus 3. I think quite definitely that's going to be 1 and 4. What combination of 1 and 4 makes negative 3? That would be 1 take away 4. Positive 1 take away 4 equals minus 3. And then we get our values of x being negative 1 and x being positive 4. Now, very close to our answer here. We've got the x values. We just need to find the y values. Remember, our original statement, y equals x minus 3. So y will equal minus 1 minus 3, which is minus 4. And y will equal 4 minus 3, which is positive 1. So those are our 4 answers. Okay, let's take a look at the next one, which I think... All right, so we're not going to do this one, but I do want to talk through it for just a sec. The reason being is because they have not made either x or y the subject here. But it doesn't take much. We know that's our very, very first step. So all we need to do is just add this y over to that side to create x equals 2 plus y, and then we're good to go. Then from that stage onwards, it's exactly the same as all the previous ones we've done. Just sub in 2 plus y in for that x value there, and then you're good to go. Let's take a look at the next one. Okay, now we're getting serious. So once again here, x is not the subject. 3x is the subject, but that does not mean x is the subject. So we've got a choice here. We can either divide by 3 to create x equals 2 minus y over 3 and sub that in, but I'll be honest with you. We're going to have to put that in a bracket and square it. I don't want to be squaring any fractions, all right? That's a bit too crazy for me right now. On a Friday evening, are you kidding me? So what we're going to do is we're going to notice that we just got a singular y over this side. With just 1 or 2 steps, we can make the y the subject. So remember, there's always going to be options. We can always make either x or y the subject. We just need to decide which one is going to be easier for us, more beneficial. If we made x a subject, we'd still get the right answer, potentially, but there'd be much more room for error. And we want to try and avoid error, if you know what I mean. So what we do is we're going to add the y to that side, minus the 3x from that side, and end up with y equals 2 minus 3x. Now, this is the first time one of our values that we're plugging in, whether it be the x or the y, has a coefficient. By coefficient, we mean number in front of. The coefficient of x here is minus 3, meaning when we're going to expand this, it's going to become a very large x squared value. So let's see what we do with this one. So we're going to plug that y equals 2 minus 3x into the top equation, create an x squared plus 2 minus 3x, and I'm going to write it out next to itself straight away because I know we're going to be squaring this shit, so we may as well just write it out like that. So the x squared will stay as x squared plus. Now, let's be really, really careful about expanding these brackets. I know I zoomed through the last couple ones, but this time we're going to take our time. 2 times 2 is 4. 2 times minus 3x will be minus 6x. Minus 3x times 2 minus another 6x. And the minus 3x times minus 3x is going to be plus 9x squared. Don't forget the squared. Just because you're putting your focus on the 3 times the 3 makes the 9, don't forget that the x times the x makes the x squared. And then that's going to equal 20. So these are some big numbers we're dealing with. Going to collect like terms, make it equal to 0, and we see what we got. So to get all in total, we're going to have 10x squared. That's a lot of x squared. Minus 12x. And then we have a 4. We're going to minus the 20. Bring the 20 over to the left-hand side to create minus 16 equals 0. So as has been the case with the previous ones, we can simplify this quadratic down. We can divide it, but it's not going to divide just to 1x squared. We divide everything by 2, and we're going to create 5x squared minus 6x minus 8 equals 0. Now that means we're going to be factorizing some tricky quadratics now. So there's a couple of methods to do this. I'm wondering whether we should do a little bit of time on factorizing these quadratics. And now that I've said it, I think it's probably a good idea. So, for those of you who struggle with factorizing quadratics in the previous questions that we did, for example, turning x squared minus 3x minus 4 into x plus 1, x minus 4, just remember, the idea is we're looking for numbers that times together to make this one and add or subtract to make the middle one. Once you make that selection, you just plug those numbers in. In this case, it was minus 4 and positive 1. When we got a question like this, there's a few different methods. I'm going to show you what I think is the best method. If you don't like it, or if you have another one, that's fine. Do whatever works for you. But if you're not sure, this is probably the method to go for. So what we're going to do when we have a coefficient of x squared, that being said is a number in front of the x squared, we're going to times it by the number at the back, number at the end. So this is going to create a 5x squared minus 6x minus 40 equals 0. So that's our first step, times the first number by the last number. Now, what that allows us to do, it's kind of a little cheat here. What that allows us to do is find two numbers that times together to make 40 and add or subtract to make minus 6. So the numbers that times together to make 40, one option we could do is quite literally just list out all of the numbers that times together to make 40. And in fact, just for the sake of practice, let's do that here. So we've got 1 and 40, 2 and 20, 4 and 10, 5 and 8, and that's all the pairs of numbers. So the numbers we're going to choose are going to be a pair that's right here. Which of these pairs of numbers can add or subtract to make negative 6? That's going to be this one. 4 and 10 can make negative 6. So what we do is we write our brackets and we write 5x in both. Now, I know what some of you may be thinking, 5x times 5x, that's going to make 25x squared. Don't worry about that just yet. Don't worry about that just yet. Got the 5x squared in the question. We write 5x in both of those. Then we're going to have 5 and 8. 4 and 10. What combination of 4 and 10 makes minus 6? That's going to be 4 take away 10. We are so nearly done. The last step, and it's an essential step here, because at the very beginning we times the first number by the last number, we times by 5. If we can divide these brackets by anything, then we do. This first bracket, 5x plus 4, there's nothing that goes into both 5x and 4, so that one stays as it is. But this second bracket, 5x minus 10, we can divide both of those by 5. So that creates x minus 2. And we can't forget that last step. If we've times it at the beginning, we have to divide it at the end. Otherwise, the numbers are just wrong. That is how we factorize these harder quadratics. Now, we're very close to the end, and we'll probably be taking a break after this question and coming back to it soon after. But here we got our values of x equals negative 4 over 5. Once again, if you're not sure how to do that, leave a comment, but after the break, I will go into a bit more detail. Just takes a minute or so to explain what's happening there. And then x equals 2 from this one. I can go back to our original statement, which told us that, well, let's use our rearranged version because we are looking for y after all now. Y equals 2 minus 3x. I'm going to write that down here. Y equals 2 minus 3x. So y equals 2 minus 3 minus 4/5. So 2 minus 3/4 times 4/5 is going to be plus 12/5, because when we do a number times a fraction, we times the number to the top of the fraction. 2 is the same as 10/5 if we're putting all in fifths. So this is going to create 22/5. And then the other one is going to be y equals 2 minus 3 times 2, a much easier equation to do. Y equals 2 minus 6, which is minus 4. So those are all of our answers. Okay, we're going to take a break now, just for 5-6 minutes. I'm going to have a little glass of water, maybe stretch my legs, get the blood pumping. I suggest you do the same. And then we will reconvene, go through a few more of these. I'll go into a bit more detail about a couple of the little niggly bits that are going on. And then we'll be moving on to some percentage stuff afterwards as well. So go stretch your legs, and I'll meet you back here in about 5 or 6 minutes. Hello and welcome back to part 2 of today's live GCSE session. I hope you walked around a little bit. Hope you got the blood pumping, had some water, refreshed the brain, and ready to get back to some quadratic simultaneous equations, like the real hard stuff, the grade 8 and 9 stuff that you will find in your exam. This is where the marks are. Even if you can't answer the question, picking up a couple marks here and there makes a world of difference. So we went through a question where the quadratic factorization section was quite an advanced one. I want to do another one like that. I don't know if it's going to be that one or another one. Oh, this was a bit different, actually. Yeah. Let's try this one. Okay, this is good. The reason why this one's different, I don't know if you spotted this. It says, give your answers to 3 significant figures. Now, when it comes to quadratics, when they tell us to give it as 3 significant figures, that is letting us know that factorization does not work. Because if it factorizes, we'll be able to write it as a number or a fraction. 3 significant figures implies it's going to be a really long, horrible number. So what that means is the quadratic formula. So this question is already telling us that we are going to use the quadratic formula to solve the final stages of this question. Now, for those who don't know the quadratic formula, you're in luck. It is given to you in your formula booklet or at the beginning of the paper. It's that one that looks like minus b plus or minus the square root of b squared minus 4ac over 2a. Hopefully you recognize that at the very least. If any of you actually memorize it, that's wonderful. Not that you need to, but it's always a nice thing. So we are going to be using that later. So I will delete it for now. And we can get back to the question at hand. So remember, when we're dealing with quadratic simultaneous equations, the aim here, the first aim is to make either x or y the subject so we can plug it into the other one. Now, the obvious one here, I'm hoping you'd agree, is making y the subject. If we make x the subject, that means we have to divide by 2. We're going to have fractions. That's not nice. We don't like fractions in algebra. So let's make y the subject. The way we do that, quite simply, is by minusing the 2x. Y equals 3 minus 2x, which means this y equals 3 minus 2x. So let's write it out again. And it's going to be x squared plus 3 minus 2x. I'm going to write that bracket out next to itself straight away because we know we're going to have to square it out. So 3 minus 2x equals 20. And let's expand that bracket. Let's expand it fully and carefully. X squared plus 9 minus 6x minus 6x plus 4x squared. You see that negative times that negative makes a positive. 2x times 2x is 4x squared equals 20. And we're used to this now, collecting the like terms. So this is going to create a 5x squared for us, minus 12x. And then we're going to minus that 20 over here to give us a minus 11. Not x, just a minus 11 equals 0. Now, this is the first time where we cannot divide by anything. But as we remember in the question, it says, give your answer to 3 significant figures. So it doesn't matter if we can't divide this shit by anything. We're going to be chucking this into the calculator. So, like I said, the formula is minus b plus or minus the square root of b squared minus 4ac over 2a. But what the fuck is a, b, and c? Do you know what I mean? We need to figure that shit out first. A is the coefficient of x squared. So in this case, a is 5. I'm going to do this in a different color because I think it's going to be more fun. A is going to be 5. A equals 5. B is going to be the minus 12. All right, not just 12. It includes the sign in front. It's a minus 12. B equals minus 12. And the C is the minus 11. Once again, including the sign before. C equals minus 11. Let's plug all this shit into that formula. So I'll put this in a little box by itself over there. So minus b. Well, b is minus 12, so minus b is going to be positive 12. 12 plus or minus square root of minus 12 squared. Now, any number squared. Oh my God, that yellow. Can you see that yellow? I'm going to change that shit. I can see it clear as day on my iPad down here. but it looks pretty difficult to see on there. So I'm actually going to change that for you guys. Change that to a 5 minus 12 minus 11. 12 plus or minus. Okay. Fixed it. You're welcome. I'll change that to A, B, and C. B squared minus 4 times minus 12 is positive 144. Now, any number squared is positive. So that number at the beginning is always going to be positive. Minus 4 times A times C. Now, I've got my trusty calculator here. I hope you guys brought your trusty calculators to the session. We're going to have 4 times A, which is 5 times minus 11, which is minus 220. So we're going to be plussing 220 because it's minus 4AC. 4AC was minus 220. So minus 220 is that over 2A, which will be 10. And then we can plug that shit into a calculator. So it's going to be 12 plus root 144 plus 220 over 10 is going to be 3.1. How many significant figures? It says 3 significant figures. We're going to do more than 3 at the time being because we're going to actually use this answer to find the other answers. So 10788, let's say. And then we change that plus to a minus. And it's going to be negative 0.70788 again, as in the 788. So those are going to be our x values. So x equals both of those. And so we're going to use those to find the y value. So remember, up here, y equals 3 minus 2x. Let me write that down here. Y equals 3 minus 2x. So y is going to equal 3 take away 2 times 3.10788. And y is going to equal 3 minus 2 times negative 0.70788. And this shit, we're just going to type that straight into our calculator. Got a nice message from Deez there saying, yo, Deez, thank you for joining us. Let's type this shit into our calculator. We got 3 minus 2 brackets, 3.10788. That one's going to give us negative 3.21576. And the other one, let's change that shit. Negative 0.70788. 4.41576. And let's not forget, we have to always leave our answer to 3 significant figures. So these ones would round to 3.11, negative 0.708, because remember that 0 at the beginning does not count as a significant figure. And these ones are just going to be negative 3.22 and 4.42. Those are our answers. So do not forget that quadratic formula exists, and the way the question hints to us to use it is by telling us to leave our answer to 3 significant figures. That's always the hint. Okay. This one's going to be exactly the same. These ones, these are fucking tough ones here, if I'm being honest with you. The reason why these ones are going to be so tough is because both the x and the y have a coefficient, meaning that we are going to make either x or y subject, we're going to have to divide by something. So for example, if we made x a subject here, this would be 4 minus 3y over 2. That is going to have to be subbed into here. So we're going to be squaring that shit. So that times by itself, which is not a nice thing to do. But it's not the most difficult thing in the world either. It would literally be just the bottom times the bottom, which makes a 4. And then the top, you just treat it like the brackets that we would do. 4 times 4, 4 times that times that times that. So actually, it's not the worst thing in the world. But for the sake of time right now, I'm going to move us on to the next topic. And then what we can do is, if we have some time, come back to something like this. So let's move on to some percentages. Now, This may be a relatively simple topic, but there's a reason why I want to spend some time doing it. It's because it's going to lead us to a more complex topic of reverse percentages afterwards. So it's really, really important we understand the formula for compound interest. So let's take a look at this question here. Perry invests 25 grand for 3 years in a savings account. She gets 2.7% per annum compound interest. That means she gets 2.7% of her money each year that she has invested. That's compound interest. So because after the first year, she's going to have a bit more money, she's going to get 2.7% on that extra bit as well. The question is asking for the total amount of interest Perry will get. Now, compound interest formula is quite simple. It's the original amount times the decimal multiplier equals the new amount. That's it. But we need to be able to find decimal multipliers. So for an increase of 2.7%, the way we find the decimal multiplier is we add it to 100, then divide by 100. So 102.7, because we're adding 2.7 to there, then we divide by 100 to get 1.027. That's one way of looking at it. But this tactic is really, really important to be able to find the decimal multiplier because it makes everything so much simpler. What we can do at this stage is just do 25,000 times 1.027, and if we and then that will be to the power of how many years? So 3 years. Sorry, I should have probably expressed that in the original equation. So the original amount times the decimal multiplier to the power of how many years equals the answer. So this is just going to be 25,000 times 1.027 to the power of 3, and the answer is 27,080.17. The total amount of interest is what the question is asking for, though. So we take away her initial investment, 25,000, to find out just what the interest is, i.e. what the bank has given her, which will be 2,080.17. So we're just going to do a couple of these questions just so we get used to the formula of compound interest. Here, Jade, so this isn't interest, but it is percentage increase and decrease. So here, Jade bought a house for 350 grand. The first year, the house price increased by 3%. Very nice. Second year, the house increased by 2%. Excellent news. Unfortunately, in the third year, the house depreciated by 5%. So she's going to be pissed off right now. But let's see how pissed off she's going to be with the fact that her house has gone down in value. So we start with 350,000. And we're going to times it. So the decimal, so it's an increase of 3%. So the decimal multiplier is 1.03. We're adding the 3 to the 100 and dividing by 100, 1.03. Then it's going to be increased by 2% after that. So we can just straight times that by 1.02 because we don't need to find this answer and then times it by 1.02. We can just times it by 1.02 straight away. And then it depreciated by 5%. That means we minus 5 from 100 and divide that by 100. So that's going to be 0.95. If you minus 5 from 100, you get 95. Divide that by 100, you get 0.95. And you can just type this shit straight into your calculator. 350 grand times 1.03 times 1.02 times 0.95. She's pissed off. It is below her original thing. 349,324.5 pounds is what her house is worth. But that's the power of decimal multipliers. Now, Leanne invests some money. Okay, I think we've got the idea of this formula. So it's just original amount times by the decimal multiplier to the power of how many years equals the new value. So let's skip past some of these. Let's try this one. This one's going to be an important one, I think, for what we're going to do next. Greg bought a new car for 18 grand. Greg's out here spending some money. In the first year, the value of the car depreciates by 30%. So that means 18,000 times 0.7. Depreciate by 30% means it's going down by 30%. So we're going to times by 0.7. In the second and third year, it depreciates by 14%. So that's going to be times by 0.86 squared. Why is it squared? Because it depreciates by 14% 2 times. So 0.86 times another 0.86. So we can just type this shit into our calculator. 18,000 times 0.7 times 0.86 squared equals 9318.96. So now that I think we've got the hang of this formula, I want to go on to something called reverse percentages. Okay, this is where people start to fuck up. This is where people lose marks and they really don't need to. Let's talk through this one. The value of a house increased by 6%. The house then had a value. Mahib Hassan, Y is at 0.7. Thank you for your comment. I will jump straight back to that and explain. So the decimal multiplier function is really, really important to understand. So the first year, the value of the car depreciates by 30%. So that means it goes down by 30%. The way we work out decimal multipliers is we do 100 take away 30%, because that's the depreciation of percent, which is 70. And then we divide that by 100, which is 0.7. So when something depreciates by 30%, you can multiply it by 0.7 to figure out what that 30% depreciation is. The reason why it's 0.86 as well is because in the second and third year, the car depreciates by 14%. So for that, you do 100, take away 14, which is 86, and divide that by 100, which is 0.86. So to find the value of something that has depreciated by 14%, you can times it by 0.86. To find the value of something is decreased by 10%, you times it by 0.9. To find the value of something decreased by 1%, you times it by 0.99. You're just minusing that percentage from 100 and then doing it as 0. Whatever that is. I hope that makes sense. We're going to go through a little bit more as well in these next few questions. So back to this one. The value of a house increased by 6%. The house then had a value of 265,000. Work out the value before the increase. So this is actually going to be using the same formula, just in reverse. So it's really important from the wording of the question to be able to figure out whether something is going to happen or something has already happened. Because this one has already happened, we're going backwards. So our formula would usually be something times decimal multiplier equals new. But here, 265,000 is the new value. We're trying to work out what it was before. So something times this decimal multiplier is now equal to 265,000. So x times, now the house is increased by 6%. What's the decimal multiplier for an increase of 6%? Well, we add 6 to 100 and then divide it by 100, 1.06. So we are using the exact same formula. But now to find x, we need to do 265,000 divided by 1.06. So whereas previously we were timesing by the decimal multiplier, we're now dividing because we're going backwards. So 265,000 divided by 1.06 equals a nice round number of 250,000. So remember, we are using this same formula, but we don't know the original amount and we do know the final amount. So we're doing it in reverse. And it's all about spotting that wording. So let's have a look at this one. In a sale, the normal price of the book is reduced by 20%. Reduced by 20%. So that's 20% decrease. The sale price of the book is 480. Work out the normal price of the book. So the sale price means after it's been decreased. Wants you to work out what it was before. So we are doing x times the reduction of 20% means it's going to be 0.8. Is going to equal £4.80, or just 4.8 for the purposes of this. So the way we're going to do it is 4.8 divided by 0.8 to move that over to that side. And we get x, very simply, equals 6. Now, we're not always going to get super nice round numbers or simple numbers like 250,000 or 6. But it's always a good sign if we do. If we don't get them, it doesn't mean it's wrong. It just means maybe check it again. Let's try this one. And that actually goes for a lot of the maths questions that come up. If you get a nice number, probably a good sign. If you get a not nice number, don't stress. It doesn't mean it's wrong, but it means you should probably have another look at it. That's sort of just a standard thing to do in exams. Okay, the value of a litre of petrol increased by 8%. It then cost £1.62. You see the language here they're using. It increased. That they're saying it has already happened, and it then cost this much. That is a trigger for us to know they want to know what's happening before. This is reverse percentages. So what it was before is x timesing by, okay, an increase of 8%. What's the decimal multiplier for an increase of 8%? I'm going to give you a second to try and think about it. If you wrote 1 point, right, because it's increased, it's going to be above 1, it's going to be above 1.08, then give yourself a nice pat on the back there. And that's going to equal to 1.62. Now, of course, it shouldn't take too much at this stage to figure out what x is going to be. It's going to be 1.62 divided by 1.08. And that gives us a lovely number of 1.5. Again, nice numbers. Not the end of the world if we don't get them, but if we do get them, we can feel pretty pleased with ourselves. Okay. After those few questions in a row, you can sort of lead yourself into a false sense of security here and start thinking, oh, I've got this, I know it. But that is exactly where they throw a curveball in. Let's have a read this question really carefully. In a sale, normal prices are reduced by 25%. Cool. I'm just reading your question. Are we assuming the original price of the petrol is X? Yes. So the idea for well, algebra in general, when you don't know what the value of something is, just call it X. So because it's asking us to find the original amount, we don't know what it is, so we're just calling it X just so we can put it into the formula. You could call it Y, you could call it A, you could call it anything. Just X tends to be our go-to. So here, in a sale, normal prices are reduced by 25%. The normal price of a coat is reduced by £12. Now, this is a bit different. Previously, it would tell us what the sale price now is. It's not doing that. It's saying that it was reduced by £12. Now, if you notice, this question, it says it's reduced by 25%, reduced by £12. That must mean 25% is £12. Because quite simply, they're saying, or not simply, but literally, they're saying reduced by 25%, reduced by £12. So surely it must be. And if 25% is £12, how many 25%? Then 100% is the original price, right? Always. 100% is just the original starting value of anything. So if we times both sides by 4, we get 100% equals £48. So a question that was thrown in there to try and trick us is actually the simplest of them all, if you can read the question carefully. So always be aware, no matter how easy a question may seem, always read it very carefully to make sure it is as it seems. And let's read this one carefully as well. Not because it's going to be a trick, but because we're now aware that it could be. So, in a sale, the normal price of a TV is reduced by 20%. Okay, reduced by 20%. Thinking what our decimal multiplier is already. The sale price, so not the original price, the sale price of a TV is $6.60. Work out the normal price, the original price. So our formula is original price, which we don't know, so we're calling it X, times the decimal multiplier, reduced by 20% means 0.8, equals the new value, which we are told is 660. So therefore, X is going to be 660 divided by 0.8. Let's see if this gives us another nice number. Pretty nice. 825. I like 825. It's a decent number. Now let's have a look at this one. The cost of a council tax bill increased. The cost of a council tax bill increased by 5%. Pretty sure my council tax bill increased by about 5% this year, and I'm pissed off about it. So this question hits me hard. Council tax bill increased by £62. Now, okay, this wording is familiar again, right? Increased by 5%, increased by £62. That means 5% is equal to £62. We want to find 100%. 100% is the original amount. So we can times both sides by 20 because 5 goes into 100 20 times. So 100% equals 63 times 20, which is £1,240. That council tax bill is a fucker, I tell you. And money comes out of my account every month. I'm pissed off. But it's got to be done. You've got to pay your ways. If you want to be part of society, you've got to pay your dues. All right. I think these questions are all basically the same. I think, yeah, there's nothing new on these questions. So I think we're probably good with reverse percentages. Just remember, it's the same formula as compound interest. Original price times decimal multiplier equals new price. You just got to figure out if the question is telling you the original and asking for the new, or it's telling you the new and asking for the original. Okay? So for those who haven't got it written down, I'm actually going to write it out for you now. Original times multiplier, and then to the power of years, if required, equals new. So just make a note of that formula if you haven't already done it. Original times multiplier to the power of years equals new. Years isn't always going to be relevant. Years is relevant mainly when it comes down to interest in a bank account, mainly. But in these type of questions, it's not really a big deal, but it's good to have anyway. I'm going to scroll back up to some other percentages that we skipped out because I think there might be a couple that are worth doing. Okay, here we go. This is the type of question they do love to throw into exams now. So I'm going to show you how to do it so you're well equipped. Nick bought a new car. Each year the car depreciates in value by 12%. Work out the number of years it takes for the car to half in value. Now this is an interesting one because they're not telling us how much he paid. They're not telling us a final amount. It's just half of the original amount. But the good thing about this now is that it doesn't matter what the price is, as long as the price halves. So you can choose your own starting value and the ending value will be when that number is halved. So let's keep it super simple here. Let's say Nick's new car was £100. We're trying to work out how long it takes to get to £50. Now it depreciates by 12%. So what is the decimal multiplier for a decrease of 12%? 100 take away 12 is 88. Divided by 100 is 0.88. So we're going to be doing 100 times 0.88 time and time again until we get below 50. So let's start with doing 100 times 0.8 to the power of 4. That means we're going to be times by 0.88 4 times. That's going to give us 59.97. So decreased quite a lot, but not quite half yet. So let's do it to the power of 5. 100 times 0.88 to the power of 5 is 52.77. Now, that's very, very close to half, but it's not half yet. So we need to keep going. We're pretty sure that the next one's going to take us over the line. Times 0.88 to the power of 6. Now we've gone below halfway. 46.44. So it takes 6 years to get halfway. Is times 0.8 the same as divide by 1.2? It is not. Really, really good question. It is absolutely not the same. It's really, really important to understand the difference between those two. If you just type it into your calculator, for example, you can see. If you do 100 times 0.88, you get 88. If you do 100 divided by 1.12, you get 89.28. So, yeah. But good question. Really important you ask those questions. Otherwise, how are you going to find the answer? Let's try question 8 again, because it's a very slightly different type of question here. Fern invests 5,600 in a savings account. She gets 2% per annum compound interest. After n years, she has this much. So, okay, so they're telling us the original amount. They're telling us the percentage increase, so we can work out a decimal multiplier, but they're not telling us how many years. So once again, this is just a bit of trial and error. We rarely use trial and error in maths, but when we do, it's kind of nice because we just try something out. If it doesn't work, it's not a problem. So we go to our trusty formula. 5,600 times 2% increase, 2% compound interest. Compound interest is an increase. So it's 1.02 to the power of, we don't fucking know. Power of x, let's just write that for now, equals 6061.62. And we're just going to try numbers out for x. So 5,600 times 1.02 to the power of 3, let's say. And when x is 3, we get 5942.76. So that's not high enough. So let's try another year. Let's see the next year when it's 4. And look at that. We get 6061.62. So that means it takes 4 years to get up to there. So as you can see, all of these questions use the exact same formula. Formulas are so valuable in maths. If you know what formula to use, it's just a case of taking the numbers that they're giving you, putting them into that formula, and then rearranging it. Or in this case, just trying stuff out on your calculator. So memorizing this formula is essential. Knowing how to use it is equally important. And we've done it so many times today. I would like to think that that you've definitely got the hang of it. Now, with a couple of minutes left, let's just take a quick look. I know this one here is a really, really horrible looking thing. Fuck it. Let's do it. We got 5 minutes left. Let's take on the hardest question on the whole fucking day. So, remember, we expressed x as 4 plus 3y over 2. And we plug that into the x squared value here. So, let's see. We got x squared, so that's going to be the 4 minus 3y over 2 times another 4 minus 3y over 2 minus 3y squared equals 13. This is going to be fucked up, I can't lie. This one's going to be tough. So we do the 4 times 4, so that's going to be 16 minus 12y minus another 12y plus 9y squared over 4. Man, I hardly got enough space to write the next bit. Minus 3y squared equals 13. Now, this looks horrible, but one of the reasons why it looks so horrible is because there's a fraction on there. And remember what I said before, we hate fractions and brackets. Whenever we see them, we want to get rid of them. To get rid of a fraction, we multiply everything by its denominator. So we're going to times everything by 4. When we times everything by 4, for everything that's on the fraction, it stays the same because it's no longer divided by 4. So that's going to be 16 minus 12y minus another 12y plus 9y squared minus 12y squared, because that's being times by 4, equals 13 times 4. Pretty sure it's 52. Let's just check. 52. Okay, looks a little bit nicer now, doesn't it? No fractions. So let's collect like terms. So we got negative 12y squared. So we've got 9y squared minus 12y squared. We're going to be minus 3y squared minus 24y. And then 16 minus 52 is going to give us minus 36 equals 0. Starting to look a little bit like something we're used to here. And quite nicely, everything here is divisible by 3. But not only 3, negative 3. So that's a really nice trick we can use to flip the signs. If we just divide everything by negative 3, it becomes positive y squared plus 8y plus 12 equals 0. And now we're back in very nice territory here. Neutral territory where we know how to take this one on. So it's a standard quadratic. Y. Two numbers at times together to make 12 and add together to make 8. I'm going to say that's 6 and 2. Positive 6, positive 2. That means y equals minus 6. Y equals minus 2. And then what were we saying before? Oh, now we've got to put this shit into this formula. So x equals 4 minus 3y. This formula up here. I'm going to copy it down at the bottom. X equals 4 minus 3y over 2. And let's plug this shit in. So x is going to equal 4, and then minus 3 times minus 6 is plus 18 over 2. 4 plus 18 is 22, over 2 is 11. And then the other one is going to be x equals 4, and then minus 3 times minus 2 is plus 6 over 2. 4 plus 6 is 10, plus 2 equals over 2 equals 5. So those are our answers. Man, that's some tough stuff. If you followed that from beginning to end, well done. I should add this live session, along with the other ones, are going to be on the Examiner's website. So if there's anything you need to have another look at, or you want to slow down, because I do talk quite fast sometimes, please do head to examiner's.com, and you will be able to see for free these videos up here for a limited time. But we went through a hell of a lot of topics over the last four or 5 weeks. So if you missed out on any of those previous topics, let me just ask this question. How did 4 plus 18 divided by 2 come? Just from the original formula up here. Remember, we rearranged that x equals 4 minus 3y over 2. I wrote it down here again. And I just plugged in the two values of y. So 4 minus 3 times minus 3 minus 6 creates the 4 plus 18, and then over 2. So that's just a bit of substitution at the end there. But perfect example of how you can jump on the Examiner's website, rewatch this, and hopefully it'll answer any other outstanding questions you have. But that'll be it from me for the time being. If you were with us for just this one or any of the previous ones, thank you so much for taking your time, and well done to you for taking some time out of your free time to learn a bit more maths and improve yourself. I think that definitely deserves a pat on the back. So go ahead and enjoy your Friday night. And you never know, we may meet again very soon. Bye bye.